So LeetCode 1663, smallest string with a given numeric value. So we define the numeric value of a character as its position in the alphabet. The numeric value of a string is just the sum of its character's numeric value. And then you're given n and k, two integers. You need to return the lexicographically smallest string with the length of n and a numeric value of k. So amongst all of the strings that obey these constraints, so the length needs to be n and the numeric value needs to be k, you need to return the one that is lexicographically smallest. And what does it mean to be lexicographically smallest? Smaller than another string? Here you have the definition, but the first part is completely useless in this problem because the length is fixed. So there can never be a prefix of another string, because to be a prefix of another string, you need to have a length of less than the other string. And here all of the strings have the same length. So then the only thing that we care about is, given the first position where we are different, and we must be different because otherwise we are equal, right? And then we are not lexicographically smaller, obviously. So if in the first position where we differ, if we come before, if the character there is before in the alphabet than the other string's character, then we are lexicographically smaller. So what this is telling you is that you want all of the characters that are bigger, that are later on in the alphabet, you want to have them at the end. Because, for example, if instead of having AAY, we had something like YAA, then we could swap around those two characters so that Y ends up at the end, and that would be lexicographically smaller. So yeah, you just want to have all of the characters that come first in the alphabet, you want to have them to the left of the string, and then all of the other characters to the right. Okay, so the way I like to think about this problem is, because we know the length that we need to return, is start with something that you know is good and then work from there. So we know that we like letters that come first in the alphabet. For example, if n is 3 and k is 3, then it's obvious that the solution is just AAA, right? So it's clear that we like A's, and we especially like them at the start of our string, right? For example, here in this example here, n is 3, k is 27. We choose to put two A's at the beginning, and then we have a leftover of 25, and so we just put that at the end. Okay, so let's just start with an array of 3 A's and then work from there, right? Because we know that the length is 3 and we like A's a lot. So just fill an array with all A characters like this, right? Start with an array of length n and fill it with the character A. And now, since you've filled the array with the character A, every A that you put is a numeric value of 1. So if before you needed like 27, then now you only need 24 more, right? We do not need 27 now because we have 3 A's already. So we only need 24 more to reach the budget, let's say, right? So remove from K the amount of A's that you've put in the array. Okay, now we're going to start from the end of the array. So we work from the back of our array. And so we have our index that starts at the last position in our array. And then we have a while loop that keeps going while k is greater than 0. So when k reaches 0 or even goes below 0, we can stop already because we have nothing more to do because our array has been prepared for that. Okay, so now what you can do is you can set the result at the current index. And then after setting it, you just want to decrement I. So you can do it real quick here in one line, or otherwise, if you prefer, you can put the I minus minus after. Doesn't really matter. So what do you want to assign to the position I in the result array? You want to assign a number such that you decrease k the most possible, right? So for example, if you can place a z, then that's the best character that you can place, because placing a z means that you have to replace less a's, and having to replace less a's means that you'll end up with a string that has more a's, and you want the most amount of a's possible. So z is the best character for that. So if k is greater than 25, then we want to place a z. But if it is, for example, 16, then we just want to consume it. Obviously, we cannot place a z, because then we would go in the negative with k, right? Like our numeric value would be too big, and we can't do that, obviously. Okay, so what we can do is we can set the value at res of I to be the string from the character code, and the base value is the character code at A, right? That's just our current value. And then we add to that the minimum between 25 and k. So this means that if k is greater than 25, then this is going to result in 25. But if k is, for example, like 16, then this is going to result in 16, which is exactly what we want. If we have enough to make a z, then we make a z. Otherwise, we do not, and we make the biggest character that we can make, which is just k, the character code from A's character code plus k, which is the leftover that we have, right? Perfect. And yeah, that's kind of it. You just now need to remember to remove 25 from your budget. This is like your numeric value budget. Once you finish this budget, you can't do anything more, so your job is finished, right? And the reason for which we always remove 25 is because this is either 25. This either results in 25, and so it's the correct value, or if it results in k, then we don't really care. We can just remove 25 because it's gonna be less than or equal to 0 in the next iteration anyway. So the value of k is not gonna matter really, right? And yeah, at the end, you just now you've assigned all of the correct values to your result array, and so now you can just return the result joined. And don't forget to put 2 empty apostrophes here, or join will put commas between your characters. Okay, and that's it. The solution has O of n time complexity and O of 1 extra space complexity. Obviously, we need O of n space complexity for the string, the result itself, but I would say that's not consumption of space. It's just that the result needs O of n space. So we use O of 1 extra space, right? Okay, so that's it for me today. Thank you for watching, and bye.